Okay, so for this activity, what I want you to do is I want you to be able to determine the angle of impact looking at these three blood droplets. Okay, so these are three different blood droplets. We'll call this one number 1, we'll call this one number 2, and we'll call this one number 3. And the first thing I want you to do is I actually want you to draw a line down the middle of these blood droplets. Now you're going to have to try your very best to draw down the exact middle, and I'm probably not going to get it right. Okay, but you're just going to do your best. See how I just tried to find the middle of the blood droplet and drew it down the center of the blood drop. And I'm going to do that for each one of these. And the first thing I want you to notice, oh, look at that, is this beautiful point of convergence down here. Mine was just about as good as you can get. And if you don't get this perfect point of convergence, I mean, that's just, you can just strive for that. That's no big deal, okay? So this point of convergence is something that's pretty significant here, because this is going to tell you how far the point of impact is from the droplet. All right, so we're going to figure this all out. So the first thing I want to do is the angle of impact. So let's go ahead. Do you remember the angle of impact equation? The angle of impact, remember, was the inverse sine of the width of the droplet divided by the length of the droplet. So I want you to practice, and I'm going to give you one of these where you actually have to determine the length and the width of the droplet, and I'm going to do this in centimeters. So it looks like the length of my droplet is 4.7, and the width of my droplet is 0.9. Okay. So I'm going to take the inverse sine of those numbers. And I got 11. So my angle of impact equals 11 degrees. All right, so what does that mean? Well, if I use a little bit of trig, and I think of a triangle here, what I've just determined is that if this is my blood drop, remember how it's spread out this blood droplet is. This is my blood droplet right here. This angle is 11 degrees. All right, here's my point of origin, or my convergence. There's the point of origin on my paper. So here's my point of origin here on my triangle. Here's the point of origin on my paper. And this is the height above the ground. Okay, so now I can use the SOHCAHTOA to figure out all of the different parts of my triangle. So for example, if I take, if I want to try to find the height, say I want to try to find the height above the ground of this point of origin, I can figure that out. All I would really need is I'd need to know this angle right here. And notice this is, if this angle of 11, this is the opposite. And I know the hypotenuse. I'm going to get it in a sec. I can get this one. Okay, so I can find the sine of 11 equals the height divided by the distance. How am I going to get the distance? Well, if I know that this is my drop and here's my point of origin, I can actually measure the distance of the middle of the drop, I think that's the middle, to the point of origin. So I'm going to go ahead and do that, and I'm going to get that hypotenuse number. Looks like this whole distance right here, from here to here, is 14.5 centimeters. That is this distance right here, or if I'm using this diagram, it's that distance right there. Okay, so I can figure out the sine of 11 degrees. The height is my unknown. The distance is known, 14.5 centimeters. And I can go ahead and solve for that. All right, so I'm going to go ahead and do that. Oops. Not using the inverse sign this time. So sine of 11 times 14.5 is going to give me a height of 2.8 centimeters, which would be this measurement right here. So this is an example of how we could reconstruct a crime scene. We could actually take 3 droplets of blood on the ground. We could figure out how far away from the crime those blood droplets traveled, all right, by figuring out the point of convergence. We could figure out how high off the ground that blood was dispersed from to give them that angle of impact. And we could figure out, of course, the angle of impact. So all of that from just 3 blood droplets. We can measure them, we can determine the distance of them, and we can see how spread out those blood droplets are. All right. So that's a great example of how you can sort of reconstruct a crime scene. I'm going to give you another example, and I'd like you to try to do that on your own. So all you really need is a calculator and a ruler, and I think you can probably come up with that somewhere in your house. Good luck. If you have any questions, let me know. Bye.